Next slide. Okay, sorry, we are just doing 1 or 2 corrections. So I continue from where I stop. The rate of reaction is just, when you're talking about the rate of a chemical reaction, you're talking about the speed. It's just as if you are traveling. When you look at kilometers per hour, in chemistry, when you're looking at the rate of reaction, you're also looking at concentration per time. That is mole per dm cube per unit time. And so the rate of reaction describes how fast a reaction goes. How fast is the reaction? Some reactions are very slow, some are very fast. And also an explanation of how a reaction occurs is the mechanism. So essentially we're dealing with 2 major things, the rate of reaction and the mechanism of reaction. So the rate of reaction is affected by factors. We're going to list some of the factors. And then the mechanism of the reaction is how the reaction is occurring. How does it occur? What is the molecular event that is happening concerning this rate of reaction? So as you can see on the screen, you see factors which affect the velocity of a chemical reaction. What are the factors that can affect your speed? For example, a trivial example now. If you are traveling from here to Lagos, how can you travel faster? You need a good car, you need a good road, you need a good driver. So it's the same thing. In chemistry, we are looking at reactions. So we need to study the speed of this reaction. So if I'm talking about speed, I'm talking about velocity. Essentially, I'm saying the same thing as the rate of reaction. So these 3 things, I will be using rate to cover them, like the velocity, like the speed of a reaction, is the same thing I'll be saying the rate of a chemical reaction. And how the reaction is taking place is what we refer to as the mechanism of the reaction. And the factors that can affect the speed, your speed, how can you travel faster to Lagos? It's like looking for a good car, looking for a good road. So what are the factors that affect the speed of chemical reactions? You have temperature of the system, you have the concentration of the reactant, you have availability of a catalyst, and then you have what we refer to as the nature of the substance. How are they? Are they in powder form? Are they in solid? If something is in solid, it will react in a very slow form. But if you turn it into a powder, it can react faster. So you can say the nature of the reactant. Very soon you will know what I mean by reactant and product. And then essentially, I'm just giving you a background of the course. For the part that I'm going to teach you, I'll give you some quizzes and I'll also give you a test. But finally, the whole course, we're going to give you a test that will cover all the 6 areas that the lecturer will teach. My name is what you see on that particular slide. I am B. Egbedi, Nancy Opako. Okay, some of the things, the key concept that we're going to be talking about, I have mentioned them before: velocities, speeds, reactants, and products. I'm going to concentrate on these key concepts this morning: velocity, speed. So I say velocities or speeds, they are the same thing. This is chemistry, so don't try to differentiate velocity and speed. Reactant, anything that is reacting, you can refer to it as a reactant. That if you indicate wherever it's going, it becomes products. You are familiar with things like that from senior secondary school. And then if we have time, we look at initial rate, we look at limiting steps or rate determining steps. Anywhere you see a slash, you can see velocity or speed. Essentially, I'm talking about the same thing. And then reactants and products, you are familiar with that. As we go along, you will see example of what you call a reactant and what you call a product. What are the objectives? In this particular unit, I have 6 units I'm going to give to you. This is unit 1. What are you expected to know? You will learn about the factors that affect the speed, and I have mentioned them in the slide before this. I said concentration can affect the speed of a chemical reaction. Temperature does. the nature of the substance does, availability of a catalyst does. So these are some of the factors. You may come across some other factors as you go to other courses, but these are the factors that I will concentrate on. Okay, at the end of this unit, I'm telling you, what are you expected to know? The unit, you'll be empowered in this particular unit to understand how some reactions occur. Some are very fast and some are very slow. If you take a trivial example, the time it will take you to cook yam at home, it's not the same time it will take you to cook beans or rice. So why is this so? Because it takes time for some reactions to be done or to be completed. So some are very fast and some are very slow. That's why you can cook an egg for some few minutes, but you can cook your beans for a very long time. It's because you want it to be well cooked. And so reactions, they depend on time. And some of them can take days, some can take weeks, and some can take a very long time. And then if you look at that slide, you will see many chemical reactions occur when we prepare. I have explained to you, when you prepare food or you are cooking something, it's something like a kind of chemical reaction that is also taking place because you want to cook it to be well done. And so whatever you are cooking depends, or the time it will take it to be completed or to satisfy you, it also depends on time. So most of our reactions are also like that. I'm giving you an idea of fast reactions, slow reactions, and the reactions that can take place for a very long time. At the end, you are expected, at the end of unit 1, you should be able to define rate or explain rate or velocity, and also explain what you mean by mechanism of reaction. And explain, you can list all the factors that affect the rate of reaction. This is what I want you to take away. This is what I can ask you most of the time. Questions I can ask you. What is rate? What explain it? Define it. List factors that affect the rate of a chemical reaction. So you can see that we have already discussed the answer. So we are working towards the answer. Any other thing we're going to be doing now is how you can understand so that you can define rate or explain rate or velocity and mechanism of a reaction. So, and then list the factors. I've already given you a trivial example. If you are traveling to Lagos, what do you need to get there very fast? I will say, I need a good car. Okay, so a good car is also a factor of your journey to Lagos. I need a good road. I need a good driver. I need fuel. You know, these are the, if I give you all those and there is no good driver, you will not enjoy, you won't get to Lagos on time. So this is a trivial example. When you come to chemistry, there are factors that can make a reaction to go faster, to be completed on time. And some of them, I've listed them. We are going to repeat them. I'm going to be talking about them one by one, like temperature, like concentration, like availability of a catalyst, and like the nature of the reactant. So this is the topic again, reaction kinetics. And then what did I say from the beginning until I get to this point? I said the topic is reaction kinetics. I'm bringing it back. What does it do? Kinetics, it deals with the speed of a chemical reaction and the factors that affect the speed or the rate of the reaction and the mechanism. And I told you that very soon I will explain to you in detail what you understand by the rate so that you can define it. And so this kinetics encapsulates all the three things I've listed, 3 points, like what is the rate of the reaction, what are the factors affecting it, and what is the mechanism. In case you are not following me, let me give you another trivial example. The mechanism is like if you are traveling to Lagos, and I give you all the things can help you to get to Lagos on time. I've satisfied those factors. But how are you traveling to Lagos? When you enter a cab, a taxi cab, how did you move? And how did you get to Lagos? Did you stop somewhere? Did you stop to buy something? Was there any hold up? Was there, that's what we call a go slow? Or the totality of that, the summary of that the event that has happened, describing effectively how you got to Lagos, that will take part of what we call the mechanism of the reaction. And other ones, like your speed, good car, good driver, and fuel, and good road, those are like factors. But how you made the journey to Lagos, the description, the molecular event, the totality of all those events that are taking place, we summarize what we call the mechanism of the reaction. So there are two things under this reaction kinetics. It is concerned with answering the question, how fast is the reaction going, and what is the mechanism of the reaction? And how fast the reaction is taking place is affected by factors such as concentration, temperature, catalyst, and points like that. So I have explained to you what is the mechanism. So let's go into detail. And then I'm taking off now, giving you the topic. I'm going to go into details now. When hydrogen reacts with oxygen, what you have is H2O, or water. Hydrogen is a reactant. Oxygen is a reactant. You are familiar with this simple equation from senior secondary school. And H2O, which is water, is the product. And the arrow will connect them. I know that you're supposed to know that. If you balance it, and then you have a balanced chemical equation, and which you understand, or which you refer to as a stoichiometric equation, it is balanced. That is not enough. If you balance it, that two molecules of hydrogen reacting with one molecule of oxygen to give H2O, or one molecule of water, that is a balanced chemical equation. It does not tell you anything much about the speed of the chemical reaction. So it is very important, it is necessary for you to study the speed of a chemical reaction. What again? We must also understand the factors that govern and affect the rate of a reaction. And which topic is dealing with this? It is what you refer to as the chemical kinetics, or you also call it reaction kinetics. I'm repeating it again for emphasis. Is the study, therefore, chemical kinetics, reaction kinetics, is the study of how reaction rates change under varying conditions. What are the varying conditions? Like the effect of temperature, concentration, the nature of the substance, and the catalyst. And again, molecular event occur during the overall reaction. The molecular event is the part that deals with the mechanism of the reaction. So these are two things I'm putting together. The mechanism, one part, and the speed, or the velocity, or the rate. If I say the speed, the velocity, the rate, essentially I am talking about the same thing. And at that speed, that velocity or rate is affected by factor. So the speed, the velocity, the rate with factors is one part. Then the way the reaction is taking place is another part. That's what you refer to as a molecular event, or the mechanism of the reaction. So the study of rate, I'm now summarizing, the study of rate of chemical reaction is called kinetics. I've done that. Questions, why are you actually studying this? It is because you want to know how fast reactions will take place. This compound that I'm preparing, is it going to react very fast if I shake it? Is it going to be like a bomb? And so I need to know the speed. I need to know how it can react. So it's very important for me to know how fast does a reaction go? So, and what is the mechanism of the reaction? So essentially what we are studying, what we are looking at, which we are going to find out later, when you're doing a reaction, ask yourself a question. How fast does the reaction go? How fast? And when you want to answer that question, you are looking at the speed and the velocity, or the speed or the velocity or the rate. And how does it occur? When you're looking at that, you're looking at the mechanism of the reaction. Okay. Okay. Now I've given the reasons to you. Why are you studying this? Essentially, why are you doing this? So you look below are some of the reasons why we are doing so. Why do you want to study the speed of reaction? Why? And the way the reaction is occurring. These are some of the reasons. How fast does a chemical product work? If you have a product, how is it going to work? How fast? If you take paracetamol and it takes 10 days for you to get the effect, is it working? But if you take it as they will give you the advert on television, you say within 30 seconds or 30 minutes, the pain is gone. And then you say it's working very fast. But if it takes days, no. So you need to know how fast that particular drug, like paracetamol, will work. So we also do that when we're studying chemicals. So how fast a chemical product will work. So that is one of the reasons why you should do that. You should study the rate, the speed of chemical reaction, and also the mechanism. How quickly and economically a product can be made. Okay, how quickly? If you produce something very quickly, of course, as an industrialist, you are interested in profit. So if it takes you a long time to produce something, and then why are you doing that? You're wasting time and you're also wasting, cost. So how quickly and economically? If you play with the factors that can affect the production of the manufacturing of that product, you manage the factors that affect it, you will be making a lot of product. And then that will follow with, high interest. So how quickly? You need to know so that you know what to manufacture and how to do it. How economically? Are you going to waste resources? A product can be made. So a knowledge of the mechanism too will help you, to modify the product. If you know how it is working, and then you can modify the product. When you are modifying the product or modifying some of the product, it's like the production of ammonia you learned in schools, senior secondary school. If you change the pressure, you increase the pressure, does it increase the manufacturing of ammonia? Hydrogen plus nitrogen, production of ammonia. You can remember Haber process and stuff like that in school. What were you doing? Say whether increase the pressure, change some of the factors. And when you do that, then you manufacture more nitrogen, from your experiment. So that is one of the reasons. Again, and this one is very important. In chemistry, we also want to know the molecular event that is taking place. It gives us a great deal. Yes, it gives us a lot of, help to understand how the reactant, it's reactant that are coming together to give you product. Hydrogen plus oxygen, they are reactant. What do you get? H2O. They are coming together to give you the product. So we need to know what is the molecular event. That means we have to study the mechanism. So that is very important. These are the factors. And this is one of the questions I asked you from the beginning, or some of the objectives that is expected of you to know some of these factors. If I ask you, name 3 factors that can affect the rate of a reaction, you've learned some of these in the senior secondary school. The nature of the reactant can affect the rate of a reaction. The ability of the reactant to come together in contact with each other. They need to come together to react to form products. If they can't come together, then they will repair and you will not get product. So ability of the reactant to come in contact with each other is very important. Concentrations of the reactant. If you increase the concentration, and then you will be able to form more. If everything goes well, then you can produce more of the product. It's like you. Let me give you a trivial example. If I give you more money, you're not likely to come and listen to my lecture. Now you will go out and start spending. If I give you more and more, you're not likely to listen to anybody. You just keep spending because you are getting more. And then as you are spending, if you are buying things, you will see what you are buying. It's the same thing. As you increase the concentration, you increase the number of molecules. They collide more, and then you form more product. That's what I mean by concentration. Temperature of the reaction system. If you increase the temperature, you increase the velocity with which they travel. So they have more energy, they collide with each other because the molecules, they need to collide to form product. And when that happens, then you form more of the product. So increase the temperature, and that will increase the rate of reaction. That is one of the reasons why mommy at home, we keep things in the deep freezer so that to reduce the temperature and the rate of decomposition of reactivity of microorganisms will decrease. But when you bring it out and you expose it, the food will go bad. So, but in chemistry, When you increase the temperature, what are you doing? Obviously, you are increasing the velocity of the molecules. They travel faster, collide with each other. They were able to attain the appropriate activation energy, and then they form product. That is why you study the effect of temperature and how it does affect the rate of a chemical reaction. Availability of an agent called a catalyst. You must have heard of a catalyst. You know, when you add a catalyst there, it can accelerate the rate of a chemical reaction, but it's not being used up. At the end, it's likely that you can recover it. So these are the things we are going to look at. Now, so far, if I ask you, what is the rate of a reaction? You will not understand very well, but we're going to go into it. But if I ask you, name 2 factors that can affect rate of reaction, you can say temperature and you can say concentration. That's all. If I say name 3, you can name the nature of the reactant. Name 4, you can go ahead. They are there for you. Factors that can affect the rate of a chemical reaction and how each of them does, performs the effect. We are going to look at that in detail as we go, through other units of this course. Okay. So I'm just repeating this for your understanding. The rate of velocity, you can see how I'm using it, rate of velocity, with which a chemical reaction is converted under varied conditions. That is under varied conditions of the factors, okay, and how they do affect the speed of a chemical reaction. You classify that as reaction kinetics. And the way the reaction is occurring, you classify that as the mechanism of the reaction. So I have talked about that. This slide you see there, it summarizes what I have been saying. Look at, so now I'm going to ask you, I've classified this lecture so far to the speed of velocity or rate. So anytime I'm using speed, I'm using velocity, I'm using rate. Essentially, I'm just talking about the same thing. So I classify it into that and the mechanism. So I am going to, first of all, discuss what is the mechanism of a reaction. I told you, how did you travel to Lagos? You can give your description. I took Okada somewhere, I enter a taxi cab, and you are giving the description, you are giving how you travel to Lagos. You are not talking of your speed now. When you're talking about your speed, 100 kilometers per hour, that is your speed to Lagos. That is your rate. Then the other part, how did you travel? Then you can give a description how you did it. That side will cover the mechanism of that reaction. That's exactly what I have here. Okay, so your steps, for example, if you took Okada somewhere, that is like a step. If you took a taxi cab, that is another step. If you enter a helicopter, that is another step to get to Lagos. So all those are steps. We're going to refer to them as elementary steps. Okay. So again, I continue with explanation of the mechanism. Explanation of how a reaction takes place or occur. It's the same thing, explanation how you travel to Lagos, the details. That also is taking care of the mechanism. The molecular event that is happening, how do they collide? How do the bonds are broken? The molecules are made up of bonds. How did you break the bonds? To break the bonds between hydrogen, a hydrogen molecule, oxygen molecules, now it changes to H2O. How did you do it? How did it happen? What is the molecular event? The series of steps that are involved, the elementary steps, how did they happen? That you refer to there as the mechanism. It summarizes the mechanism of the reaction. Take, for example, I've given you a reaction there now. This particular reaction, nitrogen 4, I think pentoxide also. Nitrogen 2 rather, sorry, pentoxide. It changes to nitrogen 4 oxide and oxygen. Look at the decomposition of that compound. It breaks and it gives you nitrogen 4 oxide and oxygen. Okay, how did it break? See the way it is. That is what we call stoichiometric equation, a balanced chemical equation that I talked about at the beginning. If you know how to balance this equation, it's not enough. So how did it happen? That will give you the molecular event. That will give you the mechanism of the reaction. What is the speed with which is decomposing to give you nitrogen 4 oxide and oxygen? That is the rate of a chemical reaction. So this particular compound, how does it decompose? Sorry, this compound, this on the slide is not very clear. If you want to write down what I have there, it's not very clear. So I'm not going to discuss it. I think the software has affected it. Essentially, what I have there is N2 O5. It will decompose to give you nitrogen 4 oxide and NO3. And then, so it has so many steps. I think I will try and give you a clear slide of this next time when we meet. What I wanted to do is the decomposition of nitrogen 2, nitrogen pentoxide. I think so. Okay, that decomposition, it follows, it goes on, it takes place, it has steps. It will decompose and finally you will get the product you have there, nitrogen 4 oxide and oxygen. It has so many steps. So when I'm explaining, I can explain how the reaction how it takes place to be able to get nitrogen 4 oxide and oxygen. When you're doing that, you are giving explanation of how the reaction is happening. And that is called the mechanism of the reaction. Don't worry about that. As next time when I meet, I'll give you a slide that is not changed the way it is appearing on the screen. Okay. Okay. Now we are going into, if I ask you all along, what do you understand by the rate of a chemical reaction? It's going to be very difficult for you to be explaining. And I'm going to explain it to you now. Either you can explain it or you can define it. When a chemical reaction occurs, the concentration of the reactant, anything on your left-hand side, when you write a chemical equation, you refer to that as reactant. The one on your right, using an arrow to indicate from the reactant, is what we call the product. As time goes on, the reactants are decreasing, and the product is being formed. So the concentration of the reactant will be reducing, and that of the product will be decreasing. It's like, what did you start with? At the end of the day, what is left? But what is leaving what you started with, we go ahead to go and form product. So it's not disappearing, it's leaving to form a product. So when you are defining your speed to Lagos, you say you travel from here to Lagos 100 kilometers, and you spend 1 hour to get to Lagos. If I ask you, what is your speed? Your speed, your average speed, so to say, is 100 kilometers over 1 hour. You can change the 1 hour to seconds. Actually, we always talk about seconds, okay? So you can calculate your speed. So many kilometers, 100 kilometers per hour, or 100 kilometers over, you change the 1 hour to seconds. So you can, that is your speed. 100 kilometers per hour is the same thing. 100 kilometers is your distance. In chemistry, that distance becomes concentration, and the concentration is recorded in mole per dmq. So if you divide it by time, that becomes the speed of the reaction. That becomes your average speed. What are we talking about? Look at equation 1a. Average rate of a reaction is like your average speed to Lagos. Sometimes you slow down, sometimes you increase your speed. But finally, you get to Lagos 100 kilometers per hour. What is your average speed? 100 kilometers over 1 hour. It's the same thing. If you perform a reaction, you know the time it takes for the reaction to take place. You know the concentration you started with, and you know what is left. And then what is left is what has formed the product. You can divide it by the total time, by the time it takes you to convert, or for the reactant to be converted to product. So we have, look at the first one, 1A, average rate of reaction. Change of reactant over time taken for the change. For example, listen, I want to give you a very trivial example now so that I can understand. This morning, mommy gave you 100 naira. Now you have spent 50, or you have spent, let me say you spent 40. How much is left in your pocket? 60. This morning, mommy gave you 100 naira, and you have spent 40 naira. How much is left? 60. How much has changed? Change from you have spent 40, and that 40 is like going to give you product. What time did mommy give you that money? 8 a.m. What is the time now? Take 12. How many hours? Whatever has been spent, that is You spent how many? How many naira? 60. Okay. And what is left? 40. Let me repeat it. They gave you 100 naira this morning. You spent 60 naira and 40 naira is remaining. And now you have spent 4 hours. So the change of the reactant, okay, the reactant is like the 100 naira given to you. What has changed? What is left in your pocket? If you spend 60, what is left there? 40. So you spend 60, and that 60 will become like product. Then divide it by the time you have. Now, since they gave you that money at 8 a.m., now it is 12. How many hours? So what has changed has formed the product. So you divide it. So that is like change of the reactant. You have a bracket there. That bracket stands for something like molar concentration. What about the average rate of reaction? So you can be dealing with the reactant, or you can be dealing with the product. And you can see the second one is change of product over time taken for the change. What is the product form? That is the second one. And the first one, what is the change of the reactant? So you can use any of them to stand for the rate of a reaction, average rate. See the first one, there is a minus sign in front of the equation on your right hand side. There's a negative sign there. It is because the reactant is decreasing with time. So you put a negative sign there because the rate of a reaction is a positive quantity. So the significance of the minus sign in front of equation 1A is to tell you that the reactant is changing with time. But if you go to the second one, 1B, you see a plus in front there. That indicates the product is being formed with time. What has been formed with time and over the time taken? What has changed for the question 1A with time over the time taken? Any of them, you can use them to represent the rate of a chemical reaction. I've also explained to you the bracket sign. That bracket stands for change in. And the bracket also stands for concentration. Concentration in chemistry is mole per dm³ or molar. So look at equation 1A and 1B. Indicate that the rate of a reaction may be defined in two ways. It's either you use for the disappearance of the reactant or the appearance of the product. So you can use any of them to define the rate. What has disappeared from the product over the time taken, or what has disappeared from the reactant over time taken, or what has appeared in the product over time taken. Any of them, you can use it to define the rate of a reaction. Let me just explain it. The rate of a chemical reaction is the time rate of change of concentration with time. The rate of a chemical reaction is the time rate of change of concentration. Time rate of change of concentration. Okay, that is a short way of also defining it. But remember, I talk about average rate. Okay, we're going to be talking of instantaneous rate and things like that as time goes on. Okay, so what one observed experimentally in determining the rate of a reaction is the change in concentration of one of the reactants or product as a function of time. So I've summarized them. If you have two reactants, hydrogen plus oxygen giving you H2O, if I want to study the speed of that chemical reaction, I will first of all study the rate at which the hydrogen is changing and keeping oxygen constant. When I'm through with hydrogen, I will keep hydrogen constant and I will study oxygen. So I will be taking each of them. So you can use each of them to define the rate of a chemical reaction. Okay. Look at that. Now, look at what equation 2. All that I've been saying, I want to explain it to you now. I'm taking a hypothetical reaction. A reacting with B. Look at A and B are the reactant. In case you don't know what is a reactant before, you have forgotten. Now, A and B are on the left-hand side. That plus means A is reacting with B. And the arrow is leading you to the product. C is a product. D is a product. You can see the subscript there. There are gases, okay? That's what I mean by that. This equation, I say, is undefined. Now get this very clearly. At the beginning, I said hydrogen plus oxygen, and that will give you H2O. That equation is defined because I've given you an element hydrogen reacting with element oxygen to give you that product, which is H2O. Okay, but now I change it to A plus B. So I use that A to stand for a reactant A, because I didn't name it as a chemical species like hydrogen. I just use ABCD to represent. A is a compound, or it can be an element. B is a compound, or it can be an element. It's like carbon reacting with oxygen to give you carbon 4 oxide. Okay, so C can stand for A, oxygen can stand for B, and then you have your product. So products can come out. And that is what we call undefined, because I didn't name it as carbon reacting with oxygen. I didn't name it as hydrogen reacting with nitrogen. So when you see equation represented by A, B, C, D, and letters like that, you refer to that as undefined equation or defined expression. Okay, look at that. That equation 2, I'm going to represent it by rate now. So this is where you need to be very careful. So you pick it. If you pick it now, you will always, explain it to any other person. Look at the rate of a chemical reaction. So the rate of a chemical reaction can be expressed as follows. Look at the rate. On my right-hand side, that rate means mole per DMQ per unit time. On my left-hand side, that is what rate stands for. I define rate that is something that is reacting per unit time. Is the rate of reaction of a compound. So the rate at which A is reacting, I will take A, I can take A, I can take B, I can take C, I can take D. I want to take A. Whichever one, they are equal, they are linked together. If I want to take A, with time, the A is reducing, B is reducing from equation 2, and C is increasing, and D is also increasing. So you say D, you know what I mean by calculus and that you learned at senior secondary school. D, A, the T. I'm just saying the rate at which A is decreasing. I put a minus sign in front of A. Minus D into the A. Look at the square. It's more per dm cube over time. It's equal to minus the rate at which B is decreasing. What is the A dt? That is the time rate of change of concentration of A. And that is what you refer to as the rate of the reaction. You can use the A to represent the rate of reaction of equation 2, or you can use B, you can use C, you can use D. How is A related to B? Look at that. The rate at which A is changing is equal to the rate at which B is also changing. Remember, A and B, they are reactants. So you remember to put a negative sign in front of B. Then it's also equal. You can take any of them. You can just say rate is equal to dA over dt to represent the speed of equation 2. Or you can use minus dB dt. Remember to put minus in front of reactant. But when you go to product, because you are forming the product is increasing. It's not like A and B that were decreasing. The product is increasing. So you put a positive sign in front of A, of a dC dt. But we don't write the positive sign. Anything that is in front there is assumed to be positive. So don't write it. D is also increasing. So you put a positive sign, but don't write it. So these are related. This is how they are related. When you want to, you can use any of them to stand for the rate of a reaction. It will become clearer as you go ahead. Okay, so look at the explanation. The concentration of A or B, they decrease, or each of them decreases during the time interval. Therefore, the change in A or B is a negative quantity. That is the significance of the negative sign in front of A and B. Okay, so the rate, why it is so, I've explained it, the rate of a reaction is positive. So you need to put negative sign in front of A. It's like you, if I ask you, how old are you now? You say you are 20. Okay. How old are you? Some years ago, you say you are 15. Which one is new? You won't say which one is the final one. You won't, if you say 15 minus 20, and then your age is minus 5. But if you say 15 minus 20, you bracket it and put minus in front of the bracket. 15 minus 20, 15, take away 20. That will be minus 4. Then plus the minus in front of that becomes positive. So your age is positive. That is the significance of that negative sign. Look at another equation. It's also not defined. Look at that. This is equation 4. Consider, okay. Consider a general equation. Look at A into A capital plus B, lowercase of b plus B capital into C plus C capital into D. A and B are the reactants. C and D are the product. Look at the small a, lowercase in front of capital A. That small a is a lowercase. It's what we call the stoichiometric factor. It's what we call the mole, the number of mole of A. Small b, lowercase of B is number of mole of B. The same thing, number of mole of C. So lowercase of A, the lowercase of A, B, C, and D, those are the stoichiometric factors. Those are the mole factors. But if you want to write the rate of reaction of this is how you write it. Look at that. The rate of reaction is defined by equation 5. Rate, look at, because A is a reactant, you put negative sign. And then you divide it by the mole concept. Okay? The stoichiometric factor. We did it, the stoichiometric factor of the equation 2 was 1. So 1 over 1 is equal to 1. That's why I didn't put, but in this case, the stoichiometric factor is not 1, it's A, small a. So you divide that with small a, lowercase. It's equal because B is also a reactant. You put a negative sign, you divide it by the molar coefficient. And then you go to C, you know C is a product, you divide it by the molar coefficient. The same thing as B, okay? And remember, remember that the stoichiometric factors will come into play when they are not 1. So you take care of that when you're writing the rate of a reaction. You can use any of them. You can use the first one, you can use the second one, the third, or the last one to represent the rate of a chemical reaction. Okay? Look at that. In a graphical form, take arbitrary equation. A going to B. Okay? And then look at that. What happened to A? The money mommy gave to you in the morning, you are using it. So it's going into B. So A is a reactant, B is a product. If you put it in a graphical form, look at the graph that is coming from up. A is decreasing. Where is it going to? It goes to, with time, it's decreasing towards 0. But it's forming B. B is increasing. If you look at the graph, they are linear graphs. But anywhere you find the slope, it's going to be relatively uniform. But look at another equation. C is going to D. This one is non-linear. So you see that C is decreasing, but it's like a curve if you do mathematics in a senior secondary school. But D is also increasing, it's like a curve. So the rate of this will be changing with time. They are running towards equilibrium. Not equilibrium like that. It could be a dynamic equilibrium or static equilibrium. So, but their running is just going up, for the D is increasing and C is increasing. So you can find the slope. The slope will be changing at any time. This will bring us what we call the initial rate of reaction. So we're going to be dealing with initial rate of reaction, which I talk about at the beginning, when I talk about the objectives of this particular unit. You should be able to know initial rate, you're able to know velocity, speed, getting information from this graph to describe the rate of a chemical reaction. So this one is different from the other graph I showed before, which is a linear plot. But this one is a non-linear plot because it's changing, it's like a curve. Okay. So I give you very quickly, just before you go, you can see quiz number 1. So I'm going to tell you what to do here now. Look at that. I'm going to explain this to you. In 100 seconds, it's like in 1 hour, you travel from here to Lagos. So the time you spend is 1 hour. The time for this experiment is 100 seconds. The concentration of A, look at A. concentration of A falls from 2.4 times 10 raised to minus 2 mole dm cubed to 2.000 times 10 raised to minus 2 mole per dm cubed. So it's decreasing. So it has changed. What has changed? A has changed. By how much? So you calculate it has fallen by what amount and what time. So you now know the change in concentration. And then you find the change in concentration, then you know the time. And then, so what is the rate of the reaction? I told you the rate is the time rate of change of concentration. If you know the concentration that has changed and you know the duration, the time it takes, just divide the concentration, the change over time. And then remember to put the right unit, mole per dm cube per second. We're going to be using seconds most of the time. But if I'm not using seconds, I'll let you know. So from what I have discussed so far, which term describes the measure of the increase in the concentration of product per unit time? Which one will you pick? And I told you rate is the time rate of change of concentration. See which of them fit in. Is it activation energy? No. Is it kinetics? No. C. Is it rate of reaction? Rate of reaction is the time rate of change of concentration. Is it reaction time? So the appropriate answer is also C. So this is how, it's just a quiz to test you whether you follow what I have done so far. And so in summary, I've discussed what is the rate of a chemical reaction, is the time rate of change of concentration with time, or time rate of change of concentration. And that deals with the speed or the velocity. And it's affected by concentration, by temperature, by nature of the substance, of the reactant, and also by catalyst and the way they can also come together. And I also talk about the mechanism, the molecular event that is taking place, or the totality of the event, of the elementary step. It is summation of the elementary step that will give you the overall summation of the reaction. We describe the mechanism of a particular event. So I have actually talked about this morning the rate. So we are going into taking each of the factors and then be dealing with them, how they do affect the rate of reaction. Later today, check. I'm going to put other units which you can look at, and then I will cover what is left here and what I'm going to upload after this class. So find out and look through so that you can follow me at 5 to 6 tomorrow. You're welcome to UI. Have a great day.